Turning back now to the disaster in Japan, we are joined by Dr. Thomas Filburn, a professor of engineering at the University of Hartford, to talk about nuclear concerns and perhaps make some sense of this issue. Dr. Filburn, Tom,
yes,
thank you for joining us. Now, you have worked on making nuclear reactor cores for the U.S. Navy. In layman's terms, what's happening at the Fukushima plant right now, and what are the concerns right now?
And if you look at a nuclear power plant, there are multiple layers or barriers or protection for the public. There's the fuel element itself. It's a ceramic pellet that's meant to resist up to very high temperatures and stay intact. There's metal cladding that goes around that. There's a reactor vessel that houses that along with the cooling water that goes around it. There's a concrete containment structure that goes around those first three barriers. And then there's pumps and valves that are meant to provide cooling for all these components inside of there. It's clear from the information that I can gather that the fuel ceramic elements have melted, and the cladding around many of them has also been melted. So those first two barriers to protect the public from contamination, from radioactivity.
Hence the word meltdown.
Meltdown, right. A meltdown is, from a plant standpoint, is bad, but from a person standing outside the site boundary may not be bad. TMI had a horrific meltdown, 3 Mile Island in Pennsylvania in 1979, and yet the radioactivity released to the environment was minimal because of that concrete containment structure that held intact. My concern right now, I guess, is the difference between the boiling water reactors that are these Fukushima plant designs and the pressurized water reactor that was the TMI plant. Slightly different concrete containment structure. I'm not as familiar with the Fukushima design, and so I'm a little concerned about the age of those concrete structures and the design differences between them. Will they remain intact? That's a major concern.
How would you feel about being there right now?
I would be nervous being on site at the plant from some of the radiation levels that I've seen. In the U.S., a nuclear worker can receive 5 rem of dose per year. I've seen dose rates in some of the press releases that indicate hundreds of millirem per hour, so that you would receive your annual dose rate in a matter of perhaps 8 hours being on site at that plant.
One of the more fascinating things I've seen in the reports that I've read is that people are being urged to stay inside. Don't even go outside and get your laundry off the line. Can the 4 walls of your home keep you safe from any fallout?
In fact, they can. There's radioactive contamination can take many forms. Radiation can take many forms. You get an X-ray, a chest X-ray. So it would take lead or many feet of concrete to protect you from that X-ray radiation. But there are many contamination particles that are airborne, that can adhere to surfaces, to your laundry, and that cannot penetrate. So you just don't want to ingest them inside your body. You don't want to get them in your lungs. You don't want to get them into your stomach. So the fact that they are outside your house and the walls have enough barrier to protect you from that type of those types of radioactive contamination.
Every nuclear power plant in Europe is being examined right now. It's a natural reaction when there's a disaster. Folks in Waterford, we talked to them yesterday. They've grown to live with the plant. Concerns, yes, but scared not by any stretch. Should every nuclear plant be looking inward right now?
It should, simply from the fact that the one linchpin that really affected this accident was, you need to keep cooling on these cores, these fuel elements, both during operation and post-operation because of the decay heat. They don't just go to 0 power when you put in the control rods. So you need some method of keeping the cooling going. And first thought is, well, you bring in electricity from off-site. Well, after the earthquake and the tsunami, that didn't happen. So every nuclear plant that I'm familiar with has their own on-site electrical generation system. And in fact, they have Millstone Unit 2 and Millstone Unit 3 have 2 separate systems that power 2 separate cooling systems. So they're completely independent of each other. So if anything happens to your one emergency power supply, you have a second one. The problem was the tsunami wiped out both of these backup generators. So we need to look at what accident are we designed for, and are there other credible accidents that we need to design for that we didn't include in our first analysis.
Tom Filburn, professor of engineering, University of Hartford, thank you for taking the time